Second.
Tak live lagi. Okay lah.
Kejap, 1 second. Alright. Okay. A very good morning and warm welcome to all participants to this webinar event. My name is Kanendra and I would like to thank everyone for joining us for the IEEE PES Malaysia Research Discourse 2021 webinar session. Today will be the first session of this research discourse, and I would like to introduce our first speaker for this session. Dr. Noor Afika Nazira Mansur received her Bachelor of Engineering degree from Vanderbilt University, United States in 2008, double majoring in electrical engineering and mathematics. She then worked as a process and test engineer with Texas Instruments from 2008 to 2014. Dr. Afika then obtained her Masters of Engineering in Power Systems at University of Malaya in 2013, and subsequently her PhD degree from University of Manchester, United Kingdom in 2018. She is currently a senior lecturer at the Department of Electrical Engineering, University of Malaya, and Dr. Afika is currently active in research, particularly in power system development and operation planning, dynamic integration of renewables and low carbon technologies, mathematical modeling and optimization of power system and network reconfiguration. She has authored multiple journals and conference proceedings and served as an active reviewer with international journals. Today, Dr. Afika will deliver a presentation on her research area titled From Theory to Practical, Distribution Network Reconfiguration. Right before we start this event, I would like to invite the moderator of this event, Associate Professor IR Dr. Ahmad Farid Abidin, to provide a brief introduction on IEEE Power and Energy Society. Dr. Farid? Dr. Farid, your mic is muted. Okay, all right.
Okay.
Yes.
IEEE Power and Energy Society, who we are and where we are going. So we have a look at the IEEE Strategic Plan 2020-2025. So the mission of IEEE is we foster technological innovations and excellence for the benefit of humanity. The visions is we will be essential to the global technical community and to technical professionals everywhere, and be universally recognized for the contributions of technology and of technical professionals in improving global conditions. We do adapt 6 core value, which is trust, global community building, integrity in action, service to humanity, partnership and growth, and nurturing. IEEE will drive global innovation through broad collaboration and sharing the knowledge, enhance public understanding of engineering and technology and resources to support lifelong learning. IEEE also provide opportunities for career and professional developments and inspire a worldwide audience by building communities that advance technical interests, inform public policy, and expand knowledge for the benefit of humanity. IEEE is the world's largest professional association advancing technology for humanity. In terms of global reach, IEEE have more than 400,000 members across 100 or more than 160 countries, and with the 123,000 members, student members, and IEEE also conduct almost 2,000 plus, almost 2,000 annual conferences. In terms of technical, millions technical documents, more than 200 top-cited protocols, plus with active standards with more than 1,300. And under IEEE, there is 49 technical societies. In terms of social impact, IEEE conduct the public policy engagements, global humanitarian efforts, education and certification, as well as ethics in technology. In terms of the PES is considered as the second largest technical society in the IEEE, part of 37 other technical societies under IEEE. And how the membership can help you. The first is to grow and maintain your technical expertise, get connected to others professionals, contribute to the futures of power and energy, as well as save money programs and materials. Stay technically proficient with PS under the online webinars and tutorial, on-site training workshop, practice-oriented technical journal, and as well as plain talk basic course, very small for our practicing engineer members. So many resources are eligible under our CEU PDH. Under the IEEE PES Resource Center, which access across 1,400 items, which is the most extensive library of content in the world devoted, which is exclusively to the field of power and energy. So there is all together the materials such as tutorials, videos, technical reports, journal articles, archive webinars, conference slides, and many more, which have been put in one platform. Global engagement through the local chapter. IEEE PES have 10 regions, where Malaysia is under the region 10 under IEEE PES. Here are the lineup of our previous leadership. Currently, our chair is Professor Insinyur Dr. Hazli Moklis. Okay, what we did under IEEE PES Malaysia, we conduct the invited lectures, conferences, awards for outstanding engineers, collaboration and linking with industries, technical activities. Finally, reach out to members and senior member drive. Become one day to be our member as a IEEE as well as a PES member. Okay, we do have a privilege or some specialty for the PES to the membership, which is eligible for 1 year. The PES member are able to enjoy a free subscription to the past awards winning power and energy magazines, gain free access to PES Resource Center with hundreds of technical reports, tutorials, videos, and presentations, receive a free membership under IEEE PES chapter, receive discounts at dozens of PES sponsored or co-sponsored conferences, as well as meeting in your area and around the world, and advantage of discounts on technical tutorials, utilize PES careers, which are free service designed to specifically help undergrad and graduate engineering students connect with employers in power and energy industry. Okay, the offer is only valid for individuals for 1 year only, and please join me as we bring more power to future. Okay, this is our email, and please, I would like to invite all of the participants to browse our website as well as our Facebooks. Okay, here are the lineup for the committee for 2021. Okay, thank you. Over to you, Dr. Kanira.
Right. So thank you, Dr. Farid, for the introduction on IEEE PES. So right now, I would like to welcome Dr. Nurul Afika Nazira Mansur to deliver her presentation. Over to you, Dr. Afika.
Thank you, Dr. Kanendra. Okay. And thank you for the brief introductions at the beginning of the webinar. So as agreed between me and the organizer, I am today, this morning, to present, to share my experience on network reconfiguration. That's my title for my today's sharing is From Theory to Practical Network Reconfiguration. So basically, towards my in the next few minutes, I will be sharing. I will start with my academic background and how did I first encounter the concept of network reconfiguration. I would also share a brief introduction on what network reconfiguration is, and then finally, I will share a project that I did with University Malaya on this topic. So. At the end, you are free to ask if you have any question if you would like to know more. Okay, so I'll share a bit of my background. I obtained my Bachelor of Engineering from Vanderbilt University, where I graduated in 2008. So after graduation, I work as a process and product engineer at Texas Instruments Malaysia from 2008 until 2014. So I would consider myself back then as a semiconductor engineer, so totally a different field from power system. So probably it was not really my forte. So I decided, while working, I decided to continue to start my Master of Engineering in where I did from 2011 until 2013 for 2 years. So towards the end of my master program, I thought of continue further. So that was when the opportunity came, and I started my PhD at Manchester University from 2014 until 2018. I was married. I am married at that particular time with one kid. So I brought my family over there. So my PhD project was related to distribution system planning. So basically, my supervisor, my PhD supervisor, Dr. Victor Levy, um, was a manager in one of the distribution company in United Kingdom before he joined University of Manchester. So basically, we incorporate all his experiences, all the problem that he saw during his tenure when he was a manager there, in my PhD project. I was actually his first PhD student. So my PhD project was about doing a distribution system expansion and operation planning, incorporating N-1 contingency analysis, with the aim to minimize the total expenditure cost and operation cost for the whole planning period. So a network reconfiguration was one of the tools that I used in my PhD project to get the desired output. So that was actually my first encounter of network reconfiguration. So after I graduated from University of Manchester, I joined in January 2019 as senior lecturer, and I am currently attached to Department of Electrical Engineering, University Malaya. So in the first few months, or I would say in the first year, I more focused towards teaching, of course, polishing my teaching skills, adapting to the environment, getting familiar with the administration staff and all. But I did, however, apply a few research grants whenever the opportunity comes. And towards the end of 2019, me and my team was awarded a research grant under Living Lab. So we proposed a project on study of electrical distribution network in for power loss reduction and potential cost saving. So the main criteria for this grant was that the research output must not only proven on paper, but it must be realized in actual, meaning the cost saving that we promise as the research output has to be a real cost saving. Okay, so this project also contributes to a few sustainable development goals, SDG 7, SDG 11, and SDG 13. So I would say this was one of the main project that I have done so far in my first 3 years of becoming a researcher. Okay, so I move on. Those who are not in this sub topic might be wondering by now what is actually network reconfiguration. So we all know that the power is conventionally generated at the generating station, transmit through a high voltage transmission line down towards the distribution network until it reaches the customer to be used. So during this power delivery, a portion of power might be lost during a portion of power might be lost in terms of heat. So these power losses is not 100% possible to be eliminated, but however it could be minimized to a certain amount. So network reconfiguration is one of the tools that we can use to reduce this power loss. So by definition, this network reconfiguration is actually changing the existing network topology or layout by changing the switch on or off status. So the lower the losses, the more efficient power delivery will be, and that would directly translate to lower bills. So if I could describe more comprehensively using a diagram, if you look at the bottom picture, I have two single line diagrams with different configuration. So the figure here on the left is a 16 bus radial distribution system. So if we zoom down to bus 8 and bus 9, we could see that these two buses are supplied from feeder 2, while bus 5 here is supplied from feeder 1. So after we model this network and we optimize with some criteria in mind, with some objective function, let's say to minimize the power losses, then we would obtain another layout which might be of the one that I showed on the right. So you could see here, uh, 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 if we look down to bus 5 and bus 5 and bus 8 now, so they are now supplied from feeder 3 instead of feeder 1 and 2 previously. So by opening the switch 8 and switch 5, we transfer this load 5 and 8 to another feeder. So that is actually what network reconfiguration is, transferring the load from one feeder to another by opening or closing a related switch. So apart from minimizing the power losses, network reconfiguration, or in short NR, could help to balance the load and prevent from feeders overloading, because we transfer one load from another to another feeder. We could also improve the voltage profile, especially on the bus that is downwards the feeder, improve the network efficiency as well as reliability. Okay, so just to give us an idea how much the energy consumption in UN and how much the bills we pay to TNB for importing the power. So I have on my slide here the data for 3 years from 2017 until 2019. So we could see that the data, the trend of consumption is roughly the same every year, where it peaks roughly during the semester. And then the total bill that UM pays to TNB, averaging to 31 million per year. So that's a lot of money actually. So if we could reduce these power losses and then um, translate these losses into a reduction in bills, that would I believe it would help a lot. It would help us to be a sustainable university in the future. Okay, so that was why our that was one of our intention of doing this project. Okay, so when we started with the project, not everything is there for us to start. Not everything is there for us to proceed with the project. So of course there are some challenges that we have to endure and encounter and find a way on how to solve it. So on the slide here is a snapshot of a portion of the network where I would like to highlight a few difficulties that we observed or we encountered during our project. So basically, uh, we there are if there is a meter at every load points that monitor that track the amount of power consumed by the users at that particular load point, that would make us that would ease our job. But then that's not the case actually. So for example, if this is the pencawan pembahagi utama, and we have two feeders connecting to this PPU. So the thing is, we do not have meter installed at this load point. And at some of the load bus downward the feeder, we sometimes the meters are not working out, so there are missing data. So I would say the main challenges was the availability of data. And we also do not know how long the distance between each load bus, how long the distance between this PPU to PE, so on and so forth. So this missing data need us to find a way on how to approximate the network as close as possible to its actual condition. So I would explain further in the next few slides on how we tackle the problem. So what we did actually. So first, these are a few steps that we planned out for the project. So for UM, there are two pencawang pembahagi utama that supply the power to UM network. PPU1 is nearby the UM scale gate with a with a capacity of 25 MVA, and we have another PPU supplying a portion of power to UM nearby where the PPU is located, the 7th residential college with 30 MVA capacity. However, only 5 MVA is allocated for UM's usage. So if I could show you the if I could show you the location of this PPU on the map. So down at the right bottom corner here, this is the location of PPU1, which is nearby the KL gate of University Malaya. And this is PPU2, nearby the 7th Residential College. Okay. Sorry, I couldn't move my slide. Dr. Kanendra, can you help? I couldn't move my slide to the previous slide. Okay. I'm back. Hopefully you could see the same slide as what I saw currently. Um, okay. After identifying the PPU supplying power to University Malaya, we also have to identify the number of distribution substation, or what we call pencawang elektrik. So basically, there are 69 pencawang elektrik supplied from these two PPU. We have been shared. We have been shared the one line diagram of the network, consisting of the 69 load bus. So each of these pencawang elektrik can only be supplied from one PPU at any time, to ease the protection and also to prevent any issue in the future. Okay, so this is the example of the one line diagram shared with us, shared with us. So this network and all the data related to the network was kept safe by the Jabatan Perbendaharaan dan Penyelenggaraan Harta JPP-HB team. So whatever data or anything that we need to do on the network, we need to discuss and get approval from the JPP-HB team, because they are responsible for anything happen to the network that affecting the power delivery and power consumption. Um, so on the picture here, you could see I highlight a few load bus that is located in the engineering faculty. So each of these load bus is labeled accordingly with the building name and everything. So it would be easy for us to see the one line diagram and then roughly know where the location of the load bus, whether it's in faculty A, faculty B, something like that. Okay, and then as I mentioned before, we do not have the official records available on the cable length. So in order for us to model the network, we need to know the length of this cable, the type of it, how much the resistance and everything. So the best we could do is to estimate this number. So we use GPS following the route, and we add up a few percentage for the margin to cater for wiring needs. So if I could show you how did we measure the length of the cable, this is the close approximation lah, I would say. So basically, we went to each of these load bus as specified in the one load diagram, one line diagram, and then we record the coordinate, and then later we go to the we go to GPS to measure the length of the cable following the route. So basically, it was a tedious job, but thank you to our research assistant and also staff from JPPHB team that help us out to identify all these 69 plus 2 PPUs location, so that we could measure the distance for our for us to start the modeling. Okay. And then we determine the electrical loading at each pencawang elektrik. So this was done based on the monthly bills issued by TNB across all PEs equipped with electricity meters. So like I mentioned before, there are some meters, there are some load bus that does not has meter. So what we did was to look at the numbers, whether and then to sync it with actual fact, whether this faculty really this location really exists, or it was no longer there. That's why there was no meter. So basically, based on the numbers, we decide whether we absorb it to the nearby load bus, or we just take it as the power loss. Okay. So once we get all the data, we model and formulate the problem using AMPL to optimize the network to find another network reconfiguration that produce the lowest power losses. So once we get result from AMPL optimization, we verified this network configuration using ETAP. So basically, we model all over again and verify whether the amount of losses we obtain in ETAP comparable to the one produced by AMPL. So once the comparison was successful, then we could roughly we could be sure what we have obtained is okay to be implemented. So what we have here is all on paper. We do not know whether whether once we implement this on the real network, it would produce the same result. So that comes the discussion with the JPPHB team who own the network. So basically, this was what we presented to them. So for initial configuration, basically, if we did nothing to the network is in its original configuration. We found out from our modeling and calculation, the power losses would amount to 229 kilowatt at any time. So if we assume 12 hours working period, and then this amount of power losses would translate to RM 444 financial losses in a year. So this was the result if we did nothing to the network. We continue with what we have so far. But then if we change the switch status, we reconfigure the network to its optimal configuration, meaning we change all the switch status or all the related switch status, then we could reduce these power losses from 229 to 170.5 kilowatt. So 170.5 kilowatt would translate to roughly 330 thousand losses in a year. So if we change the network to its optimal condition, then we would be able to save around RM 113K. That translates to 25.5% cost saving in the next year. So but then everything comes with a risk. JPPHB team has its own responsibility to ensure that the load is supplied at when needed. So we comes to we agreed to only try out on a specific location of the network. So basically, instead of go for the most optimal network configuration, we go for one pair switching, meaning we only change the switch status for for one pair of switches. So meaning if we change the switch status, we could reduce the power losses from 229 to 206 kilowatt, and that translates to RM 400K financial loss. So if we compare from initial configuration to the losses that we might obtain if we implement this network configuration, then we would save roughly around 44K or 10% financial saving in a year. So basically, this what we have agreed with the JPPHB team, and we decide if we want to proceed with the next pair of switching, or we want to go for the optimal switching altogether after we get the actual result later. If the network can still function after we change the configuration, something like that. So basically, this was our first try out lah to validate what we have obtained from our optimization with the actual data. So on the right here, this was the location and the location of the switch that we changed its status. So initially, the switch here on the top was closed. So we open this switch, and we close the one at the bottom. So basically, when we do this, we transfer these two load bus, faculty sastra lama and main library, from these two load points was originally supplied from feeder G4, and then after we do this switching procedure, we transfer these two load to G5. So as you can see here, all the changes only affect PPU2 at the bottom here. So this was also another concern raised out by JPPHB team, where they do not want to mix up the power supply from PPU1 to PPU2. So this also fulfill the requirement of the JPPHB team, where we only did changes related to one PPU at one time. Because if we mix up, for example, if we resupply few loads that was originally supplied from PPU1 to PPU2, that it might disturb the allocation, the power allocation specified for PPU2 to only 5 MVA. So so that was what we did. Okay, now after implementation, we check with we compared what we expect to get with the actual data. So this is what I will show in my slide here. So I have on my slide here the energy usage and the total bill for University Malaya for 6 months from May 2020 until October 2020. So basically, we did the network reconfiguration. We changed the status somewhere around end of August 2020. So you could see here from May until August, the electricity usage and the total bill increasing. So if I could recall it back correctly, somewhere in May or June, the MCO was released a bit. So that's why the energy usage slowly increasing until August 2020. And then once we did network reconfiguration, I think the MCO condition in our country at this particular time remains the same. So we could see a significant reduction from 456K to 365K. So and the next month also produced roughly the same amount. So we could conclude that our network reconfiguration for power loss minimization has produced a positive result. So we conclude the project to be successful lah. Uh, um, um, so this result conclude the project, and the project ended somewhere around November, if I'm not mistaken. So this was what we stopped at this particular moment lah. So you might be wondering lah, why we didn't compare to the previous year's energy consumption. It was not possible because the electricity usage during 2020 and 2021 definitely will be definitely lower compared to the previous year, because we are in MCO and we are doing online learning, so students are not in campus. So it was not possible to compare with the previous year energy consumption. So this was the best comparison that we could do. So the next plan probably to continue this project, to apply for another grant to continue this project end of this year. I hope they will open, and then probably we'll see if we could continue the project with another switching configuration, and if we could add it up another features to enhance and to reduce the energy bills much further. So uh, okay, so basically that is all my sharing for related to network reconfiguration on the project that I did on this topic. So I guess that will be all from my side. Then if you have any question, then please feel free to
All
ask.
right. Okay. So thank you, Dr. Afika. That was a very interesting presentation, and we could actually see how the theoretical part of network reconfiguration is being addressed for the practical implementation. So that was very good. I think we will start with our Q&A session. We have some questions, and I will invite Dr. Farid to moderate the question and answer session. Just before that, I would like to ask one question by myself.
Mhm.
So, Dr. Fika, based on your experience, do you think the size of the network affects the network reconfiguration process? Is it more complex if it's a bigger network?
Yes, yes, yeah. It definitely will be much complicated if we have a bigger network. So usually from theoretical perspective, um, um, doing network reconfiguration on a smaller scale network would be much easier because we have less variable, less constraint to be monitored on each bus. So as the size of the network becomes bigger, the complications arise. So that's why usually in this area, when we submit a paper, for example, reviewer tend to ask for a bigger network to test or to validate the proposed method, because it would assure that the method proposed on network reconfiguration is robust and feasible for a much bigger network.
Right. Okay, thank you, Dr. Farid. The floor is yours.
Oh, okay, any question from the audience or from participant, Dr. Kanira? Okay, from Manoj E. Okay, good morning. All great webinar. Question: can we use any intelligent technique to determine the optimal network reconfigurations? Thank you, Mr. Manoj, I guess.
Uh,
Okay.
Thank you for the question, Mr. Manoj. Yes, we can use intelligent technique. So so far I have not tried this technique yet. So far, what we have employed was mathematical modeling, heuristic techniques, and definitely with a lot more constraint, a lot more features added up into distribution network as we go into conventional network to smart grid, we might not have any other option as other than intelligent techniques to tackle this network reconfiguration problem. So it is possible, but I have not tried it yet. But there is a potential to use intelligent technique.
Okay, thank you. From Jakar Lanun, what is the AMPL stand for?
It was an abbreviation for a software. I couldn't recall it now. If I could do a simple search out. It is actually a software, AMPL software. So you
Uh-huh.
could Google it out to see.
So that means there is no such specific name. This only they put it on the type of the name AMPL, I guess. It's a brand.
Yes, like a MATLAB, something like that.
Okay. All right. Okay. Again from Mr. Manoj, what are the constraints for network reconfiguration? Should the network be radial? There is two
Uh,
questions together.
Okay. Yes. Network radiality is one of the constraints that we consider. So all the the standard technical constraint for a network, we took into consideration. For example, the power balance, the voltage limit, the thermal capacity. All those constraints were taken into account when we model and formulate the problem in AMPL as well as in ETAP.
Okay. Okay, from Jasro Jamani. Hi, doctor. May I know, have you considered the cable sizing and the unbalanced load flow during the analysis? Cable sizing and unbalanced load flow during the analysis.
Yes, we did consider the cable sizing based on the type of cable, based on the information of the type of cable shared with us from JPPHB team. So based on the type of cable, so we go with the standard cable sizing that a company would supply. So that was the best we could do lah, because we do not have the actual data. For the balanced load flow, if I'm not mistaken, we this is my I couldn't really recall, but I think we didn't consider the unbalanced load flow.
Okay, thank you. Okay, again from Mr. Jakar. How does the protective device be re-coordinated once the network reconfigured? How you manage of unforeseen threats?
Okay. I am not really an expert in protection. So from my understanding last time, before we did the configuration, we identify what are the types of breakers, fuses, and switches related at the installed at that particular location. At that at that particular feeders that we do the switching. So basically, after we identified the type and how the protective devices working on that particular location, then we double verify whether it is okay, whether it would still functioning well, whether it's still okay with the direction of current flow once we do the reconfiguration. And then we monitor after the switching process lah. From that first from that procedure, there was no issue related to tripping or anything. So
So
that would our
once
understanding.
Okay, so once the new reconfiguration have been accomplished, so far there is no such unforeseen trip or unintentional trip for the system.
No, no, so far.
Okay, okay, all right. Okay, next. Is protection of buses will be same from Mr. Samir?
Protection of buses. I am not really sure about this. How to answer on this. Then probably I could get back to you, Samir, later on this part.
I guess it's depend on the what we call it, the system that we use in the substation. Perhaps because different substation, perhaps they put a different protection. But we have to look first. I
Uh-huh.
think we have to look first in detail what kind of the protection have been installed at the substation that Dr. Noafika study. Right.
Yep, yep.
So definitely Dr. Noafika cannot give the answer, I guess.
Yeah,
Okay.
I need to check to double confirm with my research assistant. He was no longer with UM, so before I give a clear explanation, that I need to check with him.
Okay, from Mr. Muhammad Osama, interesting topics. Thanks for sharing knowledge with us. On what basis the reconfiguration performed to mitigate the power losses based on the peak load or off peak load? This basis
Uh,
on the peak load and off peak loads.
we did the configuration based on peak load. So I believe the reason why we choose peak load was because uh, we want to the we go for the worst, I guess. If we go we chose peak load because the amount of power usage would be much bigger during pickings, and then the amount of losses we would be able to estimate the maximum losses that could be happening to the network.
Okay, I think we can allow one more question, I guess. Okay, why using an up power flow? Why not using forward backward sweep distribution of power flow? After all, distribution system is radial networks, not a mesh one.
uh,
From Mr. Mohamed Shaaban.
Okay. Actually, if I could recall correctly, there is no specific there is no specific reason why we opt for NR power flow, because we did modeling using AMPL and ETAP. So basically, we choose from whatever
Available.
whatever supplied by the
Uh,
by the software.
mm-hmm. So you just pick whatever in the software, right? I guess right, isn't it?
Yes.
Okay, I can stop. Okay, we still a few questions over there. Okay, from Muhammad Izzuan Zaina. Okay, network reconfiguration is about changing topology switches with the main reason of voltage performance and influencing losses.
Uh, I don't really understand the question. Network configuration is what changing.
I think you just want to reconfirm.
Uh-huh.
Okay, the main reason of voltage performance and influencing losses, which the main reason why the network configuration is conducting. Is it based on the because of the voltage performance?
No. The
Nah.
reason, the main reason for doing this network reconfiguration is to minimize the loss. But then,
Mm-mm.
when we minimize the loss, indirectly we also improve the voltage performance. So, but then we don't really do the analysis on the voltage as well, as long as all the voltage at every bus is within the limit.
So I would conclude that actually the network configuration is focusing on the what we call it the minimizing the losses, and for the
Uh-uh.
voltage performance is come after that. It's just the
Yes,
the, the direct impact from the loss minimization. Am I
yes,
right?
true. Yes,
Okay.
true.
Okay. During the real implementation, maybe the load at any point has changed compared with the value put during optimization of network configuration. Was this change of load have been considered?
No, for our for the project that we have completed, we use a constant value for this loading. So we hasn't considered dynamic load, meaning that probably that what we could consider in the future lah.
Okay. Any more question, Dr. Kanendra?
I think that's
No
all.
more.
Those are the questions.
Okay, thank you. Very interesting session. Very interesting sharing knowledge by Dr. Afrika. And I think that's all for our session today. Over to you, Dr. Kanendra.
Right. So thank you, Dr. Farid, and also thank you, Dr. Afika, for this
Welcome.
wonderful knowledge sharing session on network reconfiguration. So thanks to all, and to all participants, please do not forget to fill up the attendance link. Thank you. Until we see you next week for the second session. Thank you.
Okay. All right. Thank you.
Everyone.